A rather strange object is drifting through the cosmos. The James Webb Space Telescope has captured images that leave even top scientists puzzled. Is it a comet, an asteroid, or something far more extraordinary?
Racing through space at an incredible 220,000 kilometers per hour, an extraordinary visitor arrived in our solar system, carrying secrets from the galaxy's ancient past. 3I Atlas, discovered in Chile's desolate Atacama Desert on July 1, 2025, has been wandering the Milky Way for potentially 7 billion years, making it older than complex life on Earth, possibly even older than our planet itself. This isn't just another routine comet sighting. It's a genuine cosmic time capsule from a stellar neighborhood that formed when our galaxy was young, violent, and fundamentally different from today's organized spiral structure. The shocking discovery that changed everything. When the James Webb Space Telescope turned its powerful infrared instruments toward this interstellar wanderer, astronomers confidently expected typical comet chemistry, primarily water vapor with modest traces of carbon compounds and other familiar molecules. Instead, they discovered something that shouldn't exist according to our current understanding of comet formation. The comet's chemistry was completely backwards from everything scientists knew. Where typical Earth-originating comets display comfortable 10-to-1 water to carbon dioxide ratios, this ancient visitor shocked researchers with an impossible 8-to-1 carbon dioxide to water ratio, a proportion never before recorded in any comet, asteroid, or planetary body within our solar system. Even more puzzling, the object contains significant quantities of carbonyl sulfide, a sulfur-bearing compound that produces a characteristic pungent odor and hints at formation processes completely unlike anything found in our local cosmic neighborhood. Dr. Stephanie Malam, Deputy Project Scientist for Planetary Science at Webb, described the team's bewilderment. "We ran calibrations multiple times, checked our instruments thoroughly, and consulted with colleagues worldwide. The data remained consistent but described chemistry that challenged our fundamental understanding." Independent confirmation eliminates all doubt. Scientific discoveries require rigorous independent verification before acceptance. The SHOCKS satellite provided that crucial validation, conducting its own detailed infrared analysis between August 8th and 12th, 2025. The results were both confirmatory and revelatory. SHOCKS detected identical anomalous carbon dioxide signatures while revealing asymmetric outgassing patterns suggesting complex internal structures. Multiple instruments from different teams using completely different calibration standards produced identical results. The chemistry was real, revolutionary, and demanded explanation. Message from the galaxy's turbulent youth. This cosmic messenger likely originated in the Milky Way's thick disk, a population of ancient stars 10 to 13 billion years old that formed during our galaxy's chaotic early epochs. During that era, star formation rates were dramatically higher, and heavy elements remained scarce, creating planetary systems under radically different chemical conditions. The comet's extreme carbon-rich chemistry suggests formation around metal-poor stars where carbon compounds could condense more readily than water ice. Such environments might exist around K or M dwarf stars with different thermal properties, or in outer regions of protoplanetary disks where unusual temperature gradients dominated. Remarkably, this ancient traveler survived billions of years of interstellar journey, enduring cosmic ray bombardment, gravitational encounters with massive objects, and interactions with interstellar dust and gas, while somehow preserving its distinctive chemical fingerprint intact. Hidden in plain sight, a communication challenge. Perhaps most remarkable about this revolutionary discovery was how it initially escaped widespread public attention, despite being published immediately in open scientific literature. The technical papers describing Webb's and SPHEREX's groundbreaking observations were made available through standard astronomical databases within days of completion. However, the profound significance remained buried beneath dense technical language that made revolutionary implications accessible only to specialists. Phrases like anomalous volatile abundance ratios and non-solar isotopic compositions completely failed to convey the discovery's earth-shaking nature to broader audiences. The raw observational data was publicly available within hours, but understanding its cosmic significance required extensive expertise, spanning comet chemistry, stellar evolution, galactic dynamics, and astrobiological implications, knowledge that few outside specialist communities possessed. Revolutionary implications for life throughout the universe. While 3I Atlas shows absolutely no signs of biological activity, its unprecedented chemistry has captivated astrobiologists studying life's potential in diverse cosmic environments. The high carbon content combined with sulfur-bearing compounds like carbonyl sulfide creates a chemical inventory that, while radically different from Earth's familiar biochemistry, might theoretically support alternative forms of life under appropriate conditions. If carbon dioxide-rich environments were genuinely common in ancient planetary systems throughout the galaxy, they might have provided completely alternative pathways for life's emergence, biology operating on fundamentally different chemical foundations than Earth's water-dependent organisms. The discovery suggests our comfortable water-rich life-supporting environment might represent an unusual exception rather than the typical galactic norm. This possibility has staggering implications for estimating potentially habitable worlds and fundamentally restructuring approaches to searching for extraterrestrial life throughout the cosmos. Unprecedented technological triumph. The successful analysis represents an absolute pinnacle of international cooperation and technological sophistication. Webb's massive 6.5-meter segmented mirror and revolutionary spectrographic instruments achieved previously impossible precision, detecting molecular abundances at parts per million levels in a rapidly moving object located millions of kilometers away. The coordination required between space-based telescopes and ground-based observatories worldwide showcased modern astronomy's remarkable capability to respond rapidly and comprehensively to completely unexpected discoveries. Within mere weeks of initial detection, researchers across 6 continents were actively collaborating to interpret the complex data. This collaborative effort exemplified how contemporary astronomy has evolved into a genuinely international enterprise, with data and insights flowing freely between institutions and nations, demonstrating the field's preparedness for revolutionary discoveries. Racing against cosmic time. As C/2023 A3-Atlas continues speeding back toward interstellar space at nearly 60 kilometers per second, the precious window for detailed scientific study is rapidly closing. Every additional measurement becomes increasingly valuable as this ancient cosmic traveler completes its singular encounter with our solar system. The comet will never return. Its hyperbolic orbital trajectory ensures this cosmic meeting represents a unique, once-in-a-civilization opportunity. After wandering the galaxy since before Earth's formation, it briefly graced our neighborhood before resuming its eternal journey through the vast darkness between stars. Future observations will focus intensively on monitoring how the comet's unusual activity patterns change as it moves away from solar heating, and whether its remarkable chemistry remains stable or evolves under changing thermal conditions. Dawn of a new scientific era. This extraordinary discovery definitively marks the beginning of an entirely new era in studying interstellar objects and their profound implications for planetary science. As detection capabilities continue improving dramatically and more such ancient visitors are discovered, each will contribute invaluable insights into our understanding of planetary diversity throughout galactic history. These remarkable objects represent natural spacecraft carrying pristine samples from stellar systems completely beyond our technological reach. Each discovery provides unique opportunities to study formation conditions that existed billions of years ago and millions of light years away. C/2023 A3-Atlas reminds us that despite our impressive technological sophistication and accumulated scientific knowledge, the universe continues holding surprises capable of completely overturning our most fundamental assumptions about cosmic processes. Our place in the galactic community. This ancient wanderer's brief but scientifically transformative visit reveals we're integral parts of a vast galaxy-wide community of planetary systems, each possessing unique chemical signatures and formation histories reflecting their diverse cosmic origins. The next interstellar messenger may already be approaching through the darkness, carrying its own precious secrets from another distant corner of our galactic neighborhood. When it arrives, we'll be ready, our instruments refined and our understanding expanded by lessons learned from this remarkable encounter with authentic chemistry from the galaxy's ancient past, fully prepared to decode whatever cosmic messages await discovery in the infinite darkness between stars.